What's up, guys? Today we're going to talk about section 3.3, complex numbers. And I'll presume that you haven't taken your notes out yet, so I'll give you a second to get out your notebook so that we're ready to go. And I'm going to get going. So first, we can't really talk about complex numbers yet because we need to talk about imaginary numbers first. So imaginary numbers, and a lot of people say that complex numbers and imaginary numbers are the same thing, but there's a little like caveat to that. It's not actually true. First off, imaginary numbers came from this problem, x squared equals -1, and mathematicians would run up against this, and there's no real number solution, and that's kind of the whole point. There's no real way to solve this. So what they end up doing is if you solve it, right, square root both sides, and we get x equals the square root of -1, that's kind of a problem because the square root of -1 also doesn't have a real value. So what they said is, okay, well, let's just call it imaginary because it's not real. And we'll just set that equal to the square root of -1, and that'll kind of solve our problem. So whenever we run into this thing right here, we'll just call it I. So takeaway, I equals the square root of -1. You have to have that. Every time you see an I, it is the square root of -1. Okay. So, you try to work with technology. It doesn't work with you. Oh, what's up, dude? Let's go. Oops, don't want to do that. Okay, moving back up. We're good. I got space. We're good. Complex numbers. Complex numbers involve imaginary numbers, and that's why people say they're the same thing. But a complex number is in the form a plus bi, where this is my real part of the number. So it's a real value, and this guy is my imaginary value. Sorry, my handwriting is awful. Deal with it. That's why it's complex, because it involves a real value and an imaginary value, and imaginary numbers are not exactly the same thing as complex numbers because a complex number has a real part like that. So we'll see that coming up. That's more Monday. We'll talk more about kind of like the two parts going on. Today we're really just going to focus on BI and how to deal with I. So I think I got this thing down. Did I figure it out? Yeah, buddy. Let's go. Oh, let's maybe not do that again. Like this probably isn't going to be a great video, but I've remade this thing like 12 times at this point, so I'm just going to go with it. I don't really care anymore. First off, a couple imaginary values. So we want to do powers of I. What's going to happen is we're kind of working through different problems with imaginary values. You're going to see that you can get stuff like I to the 18th power, or I to the 22nd power, or I to the 30th power, something like that. And we want to know how to simplify that. So we never leave I with a power greater than 1. So you can never leave that. You have to always simplify. Okay? So never leave I with a power greater than 1. So for example, and we're not going to be able to solve this just yet because we haven't done it, but if I have something like simplify I'm sorry, my eyes are kind of gross here. I to the, let's say like 17th power. Okay, that's something that we need to take care of because it has a power greater than 1, and we can't have that. We have to figure out how to get that down so that it's no longer I to the 17th. So what we're going to do is sort of make like a quick little chart. It doesn't have to be a chart really, but just it's going to sort of follow that flow. And I'll scroll up a little bit just in case you missed that. So what we're going to do first is just look at different powers of I. So let's go ahead and do I to the 0th power first, and then we'll do I to the 1st, and then I squared, and then I cubed, and I'll work it over to I to the 4th, and I to the 5th, and I to the 6th, and I to the 7th. And I would kind of encourage you to draw it like this because this is sort of the table that I'm talking about. 4 down, 4 down, the next one will be 4 down. And hopefully you'll see why in a minute. So to start, I to the 0th equals 1, because anything to the 0th power equals 1. So if we got I to the 0th, that would have been simplified, right? It has a power greater than 1, we gave it a value. I to the 1st is the square root of -1, and we're just going to call it I, right? That's what the square root of -1 is. That's why we have that value. It's I. So that's fine because it has a power of 1. We don't have to change it. But I squared, we can't leave that in a problem. If we had I squared, that's an issue. So I'm going to see if I can find a way to simplify this in terms of either a real value like 1 or something like that, or I to the 1st something. So let's see. I squared is really the square root of -1 squared, right? Because that's what I is, the square root of -1. Well, anything in the square root that's being squared is just itself. It's just -1. So I have simplified it. It's no longer I to a power greater than 1. It's actually -1. So I'm taking care of it. There it is. That's my answer. So let's move on. Let's do I to the 3rd. I to the 3rd, remember, to get higher powers, if I multiply I squared times I, when I multiply I squared times I to the 1st, remember you add exponents when you multiply them. So this would be I to the 3rd, right? But we know what I squared is. It's just -1. And we know what I to the 1st is. It's just I. So the answer is -I. That is I cubed. It's -I. And again, this is I to the 1st power, so it's -I. We're good. We're taken care of. We've gotten it so that it has a power less than 1. Or sorry, it has a power of 1. It doesn't have a power greater than. And we've reduced it. So if you ever see an I cubed, you would need to write it as -I. You don't need to the first thing. That's just to prove the point. Okay? So the reason that we have 4 columns is because what we're going to find is this is going to be one result of I to a power greater than 1. This is going to be another result of I to a power greater than 1. This will be a third result of I to a power greater than 1. And this will be the final and 4th result. So there's only 4 possibilities for I to a power, right? If I have I to the power of 17, for example, it can only be either 1, I, -1, or -I. Because what happens is we're going to start repeating in a cycle here. So let's do I to the 4th. I to the 4th is really just I squared times I squared. Well, what's I squared? I squared is -1, so this is just -1 times -1, which is +1, and you can see that we're back at the beginning, right? I to the 0th was 1, so is I to the 4th. I to the 5th, in that sort of same sense, right? Same sense, we're just kind of going through the motions here. I to the 5th is going to be I to the 4th times I to the 1st. Again, adding the exponents. If you're having a hard time with this and you're like, dude, what is he doing? Please make sure you turn and talk to a neighbor before you're out of here, because this part shouldn't be the confusing part. So make sure that you understand kind of where this is coming from, because I'm sure that some of you are already like, dude, we get it, Mr. G. And some of you are like, I don't know what you're talking about. So please make sure you're understanding where I'm getting these values from and kind of how I'm trying to break it down. I could have done I cubed times I squared. I could have done a lot of stuff. This is just kind of how I'm doing it. So I to the 4th times I to the 1st. Well, I to the 4th is 1. I to the 1st is I. So 1 times I is just I. And there we go, right? It's just repeating the cycle over and over and over again. I to the 6th is going to be, well, I to the 5th times I. And I to the 5th is I. So I times I is I squared. And we know what that is. I squared is just -1. So again, we're just repeating the cycle over and over. You get the point. It's going to just keep repeating, and we'll have either 1, I, -1, or -I. So when we have a problem like simplify I to the 17th, it can only be one of these 4 values. The way that we're going to find out what it is find out how many powers of I there are by dividing by 4, because there's 4 options, 1, 2, 3, 4. Whatever the remainder is, that's the power we want to use. So I'll show you what I'm talking about. Okay. So to answer our question of simplify I to the 17th. Essentially, I want to know if I continued this trend, I to the 0th, 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th, 16th, 17th. What's going to happen is it should turn out to be I, because it would fall into this kind of column or row in the thing, but that's a lot of work to have to count, and I don't want to have to do that every time. That's like way more than, especially if it's like I to the 78th or I to the 100th or whatever. I don't want to have to go boom, 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 boom and count down these rows every single time I want to find a value. So instead, what I'm going to do is just divide 17 by 4 and then figure out what the remainder of that is. You having a good time watching this? Oh man. Oh god. Oh no. We're off the rails. I can't wait. Whoever my sub is, I'm sorry that you have to watch this like 4 more times. Or, you know, you can just tune out. I don't know. Oh my god, what's going on? Here we go. Okay, we're good. So, where is it? Where am I? What is this? What, did I erase it? Okay, whatever, we're going. Simplify I to the 17th. So, we're going to divide 17 by 4. 4 goes into 17 4 times. We get 16. We get a remainder of 1. That is the key. So this is saying that I to the 17th is equivalent to I to the 1st power, because it has a remainder of 1. This guy is exactly where that comes from. Okay? And we know that I to the 1st is just I. So there is my solution. Take a second to look at it. We'll do another one. Okay, let's try out of the 38th. Again, it can only be one of 4 options. Either it can be -1, I, -I, or 1. Those are our 4 choices that this can end up being. So we're going to take 38, and because there are 4 possible options for it, we're going to divide by 4. 4 goes into 38 9 times. We get 36 with a remainder of 2. If you don't know how to do long division and you're like, dude, what's going on here? Then again, make sure you talk to your neighbor or somebody before you get out of here so you know what's going on. All right, 2, which means that I to the 38th is equal to I squared. Again, the remainder 2 is the power that I has to be. It's got to be the same thing as I squared, because if I kept going down that list, right? If I kept going down this list right here and I went 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, I kept going to 38, it's going to end up stopping right here in this row where 2's at. So it's the same thing as 2. So I squared, and we know that that is -1. So that's something you're going to want to remember, or like maybe memorize or whatever, that, you know, I to the 0th is 1, I to the 1st is I squared is -1, I cubed is -I. All right. Let's just keep going. I think eventually I'll get cut off by this thing, but I think we're good for now. Oh, there it is. That is so far down. How did that even happen? I'm sure one of you is like, dude, you're an idiot. And you're probably right. Okay. Operations with numbers. So